In this video, let us solve a problem based on trigonometric ratios. So this problem is going to be slightly different. It's not about finding the value of something or evaluating something, but it is about proving that two acute angles are equal based on trigonometry. So here's a question. Which reads like this. If angle B and angle Q are acute angles such that sin B equals sin Q, then prove that angle B equals angle Q. So the first part of this question is have two triangles which contain angle B and angle Q as acute angles. But the question on the whole states that if there are two acute angles and then if sine of both of them are equal, then we'll have to prove that those two angles are equal. That's what we have to do. So let's see how that is done. First of all, we need two triangles to show that these two angles exist. So say the first one is like this. Obviously, we need the right angle triangles. This is going to be Q because this is the acute angle that we're talking about. So let's name it PQR. And we need another one. So let this be B because again we need B as the acute angle. And say let's name it ABC. So now in the question it's given that sin B equals sin Q. But before that, let's first see what is sin B. Now sin theta, as we all know, is equal to opposite by hypotenuse. So sin B should be equal to the opposite to angle B is AC divided by the hypotenuse, which is AB. So sin B equals AC by AB, and sin Q equals the opposite of angle Q is PR by the hypotenuse, which is PQ, PR by PQ. So sin B equals AC by AB and sin Q equals PR, which is the opposite, divided by the hypotenuse, which is PQ. So since in the question it is given that sin B equals sin Q, we should have AC by AB equal to PR by PQ. So we have AC by AB equal to PR by PQ. Now let's say these ratios are equal to K. Let's assume that it is equal to K. So if it is this, we can also write this as AC by PR equal to AB by, what I'm doing is I'm just pushing AB in the place of PR and I'm pulling PR to the place of AB, and this is still going to be equal to the ratio K, that is same. So from this we can easily write AC by PR equal to K and AB by PQ equal to K. The reason I'm doing this, well, you'll get to know as I'm solving the problem, because briefing you about the problem now is definitely going to leave you in confusion. So as I solve, you'll know why I'm doing this, because this is not one of those problems that can be solved in a very direct way. It's not just substitute and then find the answer. Please bear with me for a few minutes and then you'll know why I'm doing it. So now considering this one, we can write it as AC equals K into PR, and we can write this as AB equals K into PQ. So now let's use the Pythagoras theorem on both these triangles now. Now say considering the triangle ABC, we've got the hypotenuse square equal to the sum of the square of the other two sides. So the hypotenuse is AB. So AB squared equals AC squared plus BC squared. And then we've got for this triangle PQ squared equals PR squared plus QR squared. So now let's consider here BC square equals AB square minus AC square. So BC should be equal to root of AB square minus AC square. And here let's consider QR square equals PQ square minus PR square, or QR equals root of PQ minus PR. Now the reason I'm taking BC and QR in particular is, now in these two triangles we've got the ratios AC by AB equal to PR by PQ. So all that is left is BC by QR. Now why BC by QR? If you take BC by QR and then if you are able to equate BC by QR to both these ratios, then these two triangles are similar triangles. Now if you can prove that the two triangles are similar triangles, then the angles are all going to be equal. So that's the whole point of similar triangle. So that is why I had to do all these things. Now again, you haven't found out why I've done this, but you know now why I took BC and QR, because now I'm going to take the ratio of BC by QR. But how is all this going to help me prove that BC by QR is equal to these two ratios? Well, I'll show you here now. So when I take BC by QR, I'm going to get this root of AB square minus AC square divided by root of, I'm sorry, I've missed the squares here. So it's PQ square minus. Now, BC by QR equals, it's very clearly mentioned here that AC equals K into PR and AB equals K into PQ. So I'm going to substitute them in this. So in the place of AB, I'm going to write K PQ, that is K square PQ square minus K square PR square, that is inside the roots, and we've got PQ square minus PR square. So now BC by QR equals, now taking K square common, we get K square into PQ square minus PR square divided by root of PQ square minus PR square. Another step of this would be, let me just draw a line here. Now after this step, I'm going to write it here. So BC by QR equals, the root of K square is K. Now let's keep this inside the root. So we've got root of PQ square minus PR square divided by root of PQ square minus PR square. Now these gets cancelled, so we get BC by QR equals K. Now we can go back here and say that AC by AB is also equal to K, PR by PQ is also equal to K. Therefore, we can write it as AC by AB equal to PR by PQ equal to BC by QR. Or in other words, AC by PR equal to AB by PQ equal to BC by QR equal to K. So this shows that these two triangles are similar triangles. So triangle ABC is similar to triangle PQR. Therefore, angle B equals angle Q. So if you need to understand this concept, you need to know the concept of similarity, which states that if two triangles are proven to be similar, then all their respective or the corresponding angles are going to be equal. So that is, angle C is going to be equal to angle R. As we can see, these two are right angle triangles. Angle C will definitely be equal to angle R. Angle B will be equal to angle Q, and angle A will be equal to angle P. So that is the concept of similar triangles, and this ends this problem.